you've now got my slides, and the title of this is really your first week with AWS Cloud. And before we get started into EC2 immediately, I think what I'd like to do is start with some of the foundations, presuming that you're new to this journey with AWS, and cover off some of the key foundations. Throughout this, I hope that you'll take on board some of the recommendations on some key activities of areas to focus on during your first week, and also learning objectives for following and subsequent weeks. For the themes of my presentation today, I'm going to focus on ensuring that we've got a secure foundation in advance, exploring these services via the console or the command line interface, and then opportunities for optimization and automation that will help you be more efficient in the ways that you use and consume Amazon Web Services. Throughout the session, there will be opportunities to ask through the webinar session questions, and we have technical experts on hand to answer those throughout the call, and I'll hopefully stop with about 10 minutes at the end to also have some additional Q&A times. In this session specifically, I hope to cover an introduction to the console, the command line interface, identity and access management, which is a service to provide role-based access controls and credentials for managing users and groups of users or within your Amazon account. Introduce services such as CloudWatch and Cloudtrail that give you a visibility into how services are being used and consumed and who's changing them over time, respectively. Introduce to you the S3 storage service and how we will use that around storage of logs in this example. The Trusted Advisor service, a real great friend for those new to Amazon to keep you on the rails and help you understand opportunities for improving how you manage your account. And then we'll get into the meat of the topic, which is designing the network for you to be able to run your compute fabric, and then use of Elastic Compute Cloud. I'll leave off on talking around some of the opportunities to improve your current process through automation and through API consumption of these services. So to get started, I hope by now you all have an account, but to sign up, you can sign up. It requires a credit card on the Amazon website, and within minutes you can have access to the AWS Console. So here's a screenshot of my console. I'm just going to call out some of the key areas. You'll see that it's quite an eye chart. There's quite a lot of services here for those that are new to the Amazon Web Services environment. You can see that there is a color coding from the orange icons, the red icons, the blue icons, the green icons, yellow and purple. Now, each of those colored groups, they generally fit into a category as they're titled, whether it be compute, storage, database, networking, administration, deployment analytics, and so on. To the right, up at the top right, it's key to understand this is a drop-down underneath your user where you can access your account management and billing and cost management, as well as the security credentials for this account or environment. To the right of it, you can choose any of the regions available to your account for where you might wish to consume these services. There are now 11 regions across the globe where Amazon provides services, and it allows you to flip between those and see which services you wish to use within any given region. And importantly, to the right is the support center, also access to the forums and documentation. So if you need to post questions or log tickets around specific areas, we do have support functions that are able to provide around the sun, follow the sun support operations that you can add within your environment, as well as forums and documentations, which is great to get started with being able to read on specific areas or services. Throughout the course of this webinar today, I'm going to focus not on the specific services themselves to begin with, but on some of the things around administering the services and the environment, the account. Making sure you've got some solid foundations around best practice in security. Looking at what you may need to do in terms of determining your network and network architecture before using compute. And then discuss some of the opportunities to use some of the deployment and management services offered to automate some of the tasks to make it more efficient for you to use and reuse these services as you continue on this journey. On the previous slide, we saw all of this through the console, but there is a command line tool and it's available on GitHub at that URL in the blue hyperlink. There's some simple instructions for setting this up, and once set up on your environment with some credentials, it exposes all of these same services but via their API via the AWS command line interface. I would highly recommend that you do look at this early and understand that really you're looking at the same services, just a different view from the command line. Using the command line interface, once it's installed, it has a autocomplete capability. You'll see at the top I've typed AWS and then tab, and it showed me all of the services that are available. By putting in the service name, it shows me the methods and operations for that services. And more importantly, by typing in help, on the bottom left of the screen, you can see it gives me inline and very detailed help around the specific services and how to use them. They really are one and the same services that you would see through the console or through the command line, and becoming familiar with seeing them in both is really good early to understand and become more familiar with some of the topics we'll talk about of automation towards the end of this webinar. The first service that I'd like to focus on is under administration and security, and it's the Identity and Access Management Service. This provides me a capability to create groups which can have many members attached to them, set policies at a group level or individual roles, and just decide how services can be consumed within an Amazon account through a role-based access control. It starts least permissive, and it's a different set of credentials to those that you receive when you create your account. Those ones that you use to create your account we refer to as root or billing credentials, and best practice is to enable multi-factor access or second factor through use of a physical or a software token. So you'll see here on the IAM screen, when I go into that from the console, there's these 5 tick boxes in green down the center of the screen. The first being activating multi-factor auth, and you can do this. I use, in my example, Google Authenticator, which is a TOTP token generator. You can also use Gemelto tokens or anything that produces TOTP tokens, but it provides additional security around the access as the root user into this account. Once I'm in this account, I can start creating groups of users, maybe admins, developers, read-only, these sorts of types of groups or roles. And then I can look at individual permissions that I assign to those groups and users that I manage within that. So this really allows you to create least permissive access to your environment and permissions to access specific services versus all services, which is what your root account allows. It's an anti-pattern to share your root credentials as opposed to start using named users or groups within identity and access management. So that would be my first tip for today, to get you started with the right access control to your environment. Some best practices just detailed here, such as creating individual users and assigning them credentials in the form of username and password or access key and secret key for API on a user level, managing the permissions at a group level, and doing that at a least privileged. We'll show some examples later where I do that around some logging. Configuring your password policy for the users within this account and enforcing that. Potentially for each of these users, also enforcing that they use multi-factor auth and second factor. The configuration of roles. Now these are useful for both your EC2 instances, which I'll come to later, to enable access to specific services to your EC2 virtual machines or Elastic Compute Cloud, as well as useful for use cases such as federated identity management and access. Sharing can be used within the account through IAM roles, but it can also be used inter-account, which is a bit more of an advanced topic. IAM will also let you deactivate users' credentials, rotate users' credentials, and also set specific conditions on their access to the environment, such as that they log in from certain IP ranges during certain times of the day, as an example. The aim of this is what we want to do is reduce any use of your root account credentials, which should only be used around the account and billing management functions in that top right section of the nav, not when using specific services within the console itself. So you can log in with IAM credentials to the console and to the command line interface or API, and that would be the first practice I would encourage. The next thing I would introduce is Trusted Advisor. Now, there are a number of free checks that are provided to all users with an Amazon account, and they can be expanded through high levels of support enablement through business and enterprise support. But if you get used to this tool early, I would encourage it. It runs a number of automated scans within your AWS account and creates some observations and reports back to you, some areas which can be improved in the areas of cost optimization, performance optimization, security, as well as fault tolerance. As an example, I'm going to go into a lens view of some of the security observations within one of my accounts. So these may be things like the firewall settings known as security groups in EC2, whether or not they should be more hardened or whether they're allowing a certain access that we might want more constrained. But for a web server, I might want to silence that report. Going down, I can look through these. On that last one, it introduces the notion of Cloudtrail or logging. So that's an area that I'd like to drill into and understand a little bit more about the Cloudtrail service, which is the next one in the top right under Trusted Advisor. So looking into the Cloudtrail logging, Cloudtrail is a account-wide service that enables me to record all of the actions that my various users are doing within the account, such as configuring specific services, creating instances of specific services, or changing the properties such as the firewall rules or attributes of my services. So this is a non-repudiation audit and logging capability built into the account management function. I would encourage you to turn this on. Whether or not you're actively going in and looking at it and monitoring it in your first week, I think is highly unlikely, but turning it on and having it capture your logs for each of those regions is something that I would certainly put in your runbook for getting your account in good shape. So once it's turned on and logging, you need to create an S3 bucket, which I'll show you an example of in a moment. But it will start looking at all of these services as you start to use them. Elastic Compute, Virtual Private Cloud, Identity and Access Management, and as you start making changes, it starts delivering log files around what has changed, by whom and when, which is a really good way of understanding, particularly if it's multi-user access to your accounts, of who's changing what and when, as well as reviewing your policies for the security controls of what should be enabled. Going into Cloudtrail itself, it's as simple as creating a new bucket which you can automatically create. In this case, I've already created a bucket which is a storage namespace inside the simple storage service, or S3. It would allow me to create a bucket, or in this case nominate one of my buckets. So I've nominated one of my buckets, and then for each of those regions in that drop down of the console, I need to go through and activate Cloudtrail to start capturing and logging changes in activity against this specific S3 storage. For the first week, I wouldn't suggest that you do too much more than that, but it's good to start capturing a log history of what's changing, by whom and when. In this case, it's showing an example IAM or S3 resource policy, and this is a document. This is a sample document that is available within the documentation, but it's allowing specific operations for Cloudtrail to write to my storage bucket. And in this case, it's saying in the first statement a policy which says you're allowed to list the files that are stored in this S3 bucket. In this case, I'm allowing it from 2 of my AWS accounts, which are the pink highlighted rows for root. And I'm also allowing a write policy. So this is just configuring from a least permissive where Cloudtrail is not allowed to write to my S3 bucket, for this specific S3 bucket, allowing it the policy to put my logs there. Now this is all available in the documentation and a guide to set up this logging, but it gives you a visibility of how that account is being managed in all of the regions and how services are being configured should you need to debug in future who's changed something. The next service I'd like to touch on, still under administration, is the CloudWatch service. Rather than a non-repudiation log of what's changing and by whom, this is a service that provides monitoring of what's running and the various performance and telemetry metrics. So it understands all of the various services such as DynamoDB, Elastic Block Storage, Elastic Compute, and so on. I won't go into each one of those services, but for each of the services has a number of metrics which is able to track and monitor. I'll allow you to explore those on a service-by-service basis, such as with EC2 being able to look at how much CPU is being used or how much disk activity is occurring or how much network I/O is occurring and these sorts of telemetries. But one of the key monitoring and alarms that I would encourage on a new account would be to create some billing alerts. So for your Amazon account, you should have a fair understanding of what you're intending on doing in it. If you look at some of the costing and price estimation tools, which I will come to later in this session, you should be able to have a fair understanding for this account what would be the expected usage behavior, remembering that this is a utility environment, and if you leave things running, they can incur cost. So in my own accounts, I've set up billing alarms to tell me at certain thresholds when I am projected to cross those thresholds. Now, it's not just after the fact. It can actually look at your current rate of consumption and then look at the calendar month and say, at this rate of consumption, you are likely to incur fees at these thresholds. So there's a technical guide to setting this up within your account, but it's another great thing to do in your new account and configure things like notifications to your email address to just warn you if you've left things running or forgot to tidy up and things are costing you money which you perhaps did not intend to. So now we've got some basics. We've done some of the hygiene around security, logging, setting up some billing alerts. We can go on and talk about some of the services. And one of the first services I'd like to talk about is the Elastic Compute Cloud, or EC2. It's available through the console or through API, whether you use the command line tool or the SDKs. But I think for most people, getting familiar with using it and configuring it through the console is where people get started. But before they do that, we will have to cover off some of the networking, and this is the Virtual Private Cloud Networking, or VPC, and build a network topology or a foundation, and I'll give you some guidance on some of the basic patterns and some of the quick ways to get that started. But first I'd like to talk to you a little bit about EC2 and the various virtual machines that we offer in terms of their hardware configuration. So AWS provides a variety of host servers with different chipsets, different architectures. On top of that, provides a Zen hypervisor, and then provides virtual machines or a facility for guest machines known as EC2. You can have multiple types of EC2 instances, and they come in different shapes and sizes with different balances and characteristics, both for compute allocation, memory, storage, whether or not they're enhanced for graphics processing or network I/O. To help you understand, given that this is quite a rich assortment of EC2 instances that are now available, I believe at my last count in excess of 40 different types, it's quite key to understand the naming of instance types. So they're broken into essentially three parts. The first part here, as you can see with the C, it's about the family, and there are 15 families now, and I would help you understand these by saying that it's essentially the latest generation family and the previous generation family for all instance types. And each of those two types are broken into these categories of optimization, whether it's optimization for graphics, compute, memory, I/O, or just general purpose. So that first letter is quite significant in terms of it indicates what characteristics this machine will best perform in. When looking at a machine that's optimized for memory, as an example, you'll find that there can be a generation 1, the older instances, and a generation 2. There is a performance and price benefit for generally using the newer instances. They generally show a better performance cost profile than the earlier instances, and we encourage customers to use the latest and greatest instance types. So that instance generation is indicated with the next letter, in this case C3s, and you can see that with the release notes of the various optimizations and types. There is details on the EC2 documentation part of our website that helps you understand both the performance characteristics and the generation of these instances. Once we know those two parts and we know which type of instance family we want, we have a number of t-shirt sizes from micro all the way up to 8 extra large, small, medium, large. And this really will help you size your instance to not only the optimized characteristics, but the right size for that, whether it's 4 gig of RAM, 8 gig of RAM, 16 gig of RAM, as an example. It allows you to choose a cost profile based on that amount of resources. I would emphasize that the sizing is generally doubling per t-shirt size, as is the cost. So there's no real benefits for just oversizing, and it really is an art for choosing the right optimized instance type for your given workload. Before we can start to use EC2, however, we need to think about creating a network to run our host machines or VMs on, and there are a number of options here and components, and this can be for those that have not come from a networking background. In some cases, it's quite complex. So hopefully what I'll be able to share with you is some quick start tips of how to get started. But for those that are more familiar with networking, talk about some of the more advanced topics that you might look into in terms of designing very specific software-defined networks. So I'll cover off some of the basics of VPC, but there's other webinars throughout the course of this week for those that want to go deeper into these details, as well as white papers for helping you design and architect the right solution for your specific needs. So within VPC there are many features such as routing, the ability to attach internet gateways so that your machines can see the internet, or customer gateways such that you can connect to these machines from your on-premise environment, virtual private gateways for accessing your environment from the cloud via these IPsec or direct connect links. I'll talk about elastic IPs and public IPs, which is public IP addresses that you can assign to your machines. For example, if you're wanting to host a website and needing to put DNS records to it. And then talk about some of the things such as subnets and route tables and elastic network interfaces, but not go too deep, because this can be an area that you don't need to cover in too much detail if this really is your first week, but definitely an area to understand more than the basics. For customers that don't really care for designing explicit networks, we do provide a default network, and most of the decisions around this are very logical, and it very much mirrors the behavior we had prior to virtual private cloud being created as a service, a mode that we called classic networking. So in this, we will create for a user the first time they launch an EC2 instance, a default network. We'll create some subnets for those EC2 instances to reside in, and we'll create 2 subnets, and this is really starting to yield some of the details around the regional design of AWS. For each region, we offer multiple availability zones. And this is a construct around high availability. And best practice is to architect and use your workloads across multiple availability zones. Each availability zone provides a cluster or location of data center, if you think of it that way. But if you look at the characteristics of availability zone A to B, they are shielded from some of the environmental constraints that might affect a workload, such as floodplains, power grids, network links, and all of these external environmental factors around high availability. And so for customers, we've simplified this in terms of being able to design around availability zones with confidence that should an environmental factor affect a given data center, it should not affect the workload in another availability zone. So this is engineering that's done as a baseline for customers to be able to design high availability in their solutions by using 2 or more availability zones within a given region. So the default VPC will define subnets to span multi-AZ, as we call it in AWS. It uses a CIDR or a network range of 172, which is an internal public, and it sets up a default route in the main route table so that your instances can connect to the internet through an internet gateway. That's all it does. You can certainly configure it and change it as your needs evolve, creating additional subnets or creating virtual private gateways and other features. The pattern that I would encourage or discourage or encourage you to move away from is this pattern where you put all of your servers within a VPC, within a public subnet, but contained within just a single availability zone. So here you can certainly improve the ways that you provide availability around your solution by leveraging additional availability zones. There's lots of details on our website about the regional design and using multiple availability zones for improving availability of solutions. Generally, this pattern will move more towards this, where you may want to have the ability to provide EC2 machines that are capable of servicing public traffic over elastic or public IP addresses. So in this case, we've got a NAT instance. We may even put things like elastic load balancers as seen centered on this diagram, or specific web servers or jump hosts that we wish to connect to within our public subnet, but design within our VPC architecture additional subnets to host private address range private zones. The difference between these two grey and green subnets primarily is the attachment of the internet gateway to the public subnets, which means that those public subnets have a way of getting out to the internet via their route table. And they also have the ability to be assigned public or elastic IP addresses, which the elastic load balancer also gets. So these can create a surface area for you to connect or manage DNS to, such that you can expose services to the internet. But this is not the default and not mandatory for services. The VPC provides a construct where you can completely encapsulate your workloads with no public-facing or internet addressable connection. It does also provide capabilities through the virtual private gateway to connect it just to your premise or both to the premise and to the internet. There's more details on that, but I thought for the more advanced topic, this is a pattern that we see quite regularly amongst our more mature customers, where the customers may design multiple software-defined networks or VPCs to isolate specific workloads from each other. With the advent of VPC peering, it allows you to connect inter-VPC workloads together. So here we can see in the center of this AWS account, we have a services VPC with services like Active Directory, DNS, monitoring, logging, these sorts of services that may be common within our applications being hosted within a specific VPC, whilst each of our application workloads are contained within their own network range and network VPC. This is not something I would encourage you to design without some consultation and help from AWS, but it does help you understand where more larger enterprises can design workloads with multiple networks and VPCs. You can see at the far left here that there is actually a containment of a unique public-facing web app in its own network. In fact, the right icon there is it's in its own account. And so there's a lot of flexibility in the ways that you can share between accounts and the ways that you can share between one or more virtual private clouds But in your first week, I would say it's really a decision about how to use the default VPC if you're not wishing to design an explicit network, and understanding that default VPC and going in and exploring how that's created for you, or using some of the templatized wizard-based creation mechanisms for a more custom VPC before getting in and defining your own explicit VPCs on network ranges that you decide are appropriate for your organization. Remembering that you can continually change and optimize this later. It's not set in stone, but it is good as a foundation before you start thinking about creating your compute. In the old world, we used to have to do a lot of planning because the build phase took many months in many cases, including the ordering and waiting for equipment. And once we had it running, there wasn't a lot of opportunity to go back and change some of the decisions that we made up front. Whereas in the cloud world, we can provision resources and make changes within minutes and roll them out entirely in an automated fashion when tooled well. And so this does liberate us in terms of being able to think more incrementally about our environment and how we may add to it, change, modify or improve it as we continue on this journey. So I wouldn't worry too much about getting it all designed up front versus getting just a solid basic foundation and process early on. Some of the things that I'm now going to talk to about are once we have our network and we have an ability to launch our EC2s into our various subnets is looking at ways that we can use and optimize some of the aspects of this, which includes thinking about our environment as more dynamic than static. There are opportunities for our EC2 instances to be turned off and not being billing when not needed to be used. So there's some classic examples that I'll go into, maybe dev and test. There are features around these instances to automatically design clusters of EC2 machines that will scale horizontally, adding more machines under duress and shedding machines under periods of lesser workload, so that we can be cost conscious and only use resources when we need them. There are also billing mechanisms such as reserved instance pricing or spot instance pricing that help us make more efficient use or cost optimized use of the EC2 resources that we need. And there are also other services such as optimization and cost around our S3 storage classes, so looking at features for optimizing storage, optimizing our requirements for database read and write provisioning, and also optimizing by offloading traffic through use of high-level services. So the first practice that I would say to start thinking about within your environment is, as you're provisioning instances, are there opportunities for you to start terminating them at certain times of the day? A classic example is that your developers might only work 9 to 5, 12 hours of the day. So there might be opportunities at 8 p.m. to turn things off and 8 a.m. to resume them through some of the automation techniques that I'll come to later. Or simply just turning things off when you're not in use, stop and start. A great example of this is if you're using jump hosts or bastions. It not only enhances security by turning them off when not required, but it also enhances cost by not having them billed when not in use. But later I'll talk to, at the end of this, I'll also talk about how you can automate some of the techniques of creating your virtual private cloud network and loading or launching your EC2 VMs within your network and doing this in an automated and a predictable manner such that you can provision resources just as you need them, work on them and turn them off if not required. Thinking about your environment as being disposable or being able to be recreated is a different mentality when it comes to cloud. Being able to use things on utility, it's a mind shift for users to think about how they can use these more dynamically for both cost, for cost advantage. And one of the key areas for you to start learning about is automation. I'm going to touch on just one of the frameworks, which is CloudFormation, and provide some examples. I believe there's webinars that will go into that in more detail through the series of webinars this week, and there's lots of really detailed guidance, examples and documentation around known workloads and use of CloudFormation. I haven't mentioned until now, but also the use of tagging, which is something to think about early, is in terms of if you need to start allocating the costs of this utility to various lines of business, cost codes, individuals, etc. Throughout the AWS environment, services that you can consume have the ability to tag. And tagging is a set of key value inputs that you can create, and they follow the life cycle of those resources and their billing events. And this gives you, through the billing visibility of your billing and account management, visibility into where your spend is being used. So looking into tagging, particularly around EC2, is a really good practice to understand before you start creating multiple EC2 instances and start losing the visibility as to where your costs are being incurred. Learning about auto-scaling. Not only can you turn things on and off when not needed, but you can schedule things or alarm them to automatically provision more instances as required. The classic example here is, say, a website that might have seasonal workloads. You can configure through CloudWatch, the service I mentioned earlier, for billing alerts. You can configure behaviors to adjust the desired capacity of an auto-scaling group and increase the amount of web servers in this diagram on the right during periods of peak activity, and decrease the amount of web servers used in a load balance cluster during periods of low activity. So this has a huge impact on both availability in terms of designing services that can scale under load, but also cost in designing a behavior where your workloads are not always running at your peak usage threshold. There's additional features such as reserved instances. Now this is an example of just one instance, and if you think of the EC2 instance, it has an on-demand price, which is the list price that is the hourly price per usage billed per hour. In this example, I'm using a Generation 1 instance, the M1 family of type T-shirt size large, and looking at it as an annualized utilization cost. In the far left column, it shows you sort of the optimal usage scenarios, up to 30% utilization. Once we cross that threshold and we start looking at towards the right, as we progress to the right, some other optimal bands of looking at utilization patterns where you can optimize through use of reserved instances. Reserved instances is a mechanism by which you pay an upfront small fee to secure a discounted hourly price. So the payback period varies. Now the duration is typically 12 to 36 months, and it has a payback period depending on 12 or 36 months, somewhere between 3 to 7 months for that instance type. So it's an optimization that we can do around cost, also around availability or capacity planning for our EC2 fleet. In addition to reserved pricing, there are mechanisms for spot pricing. In periods where we have excess capacity, Amazon provides spot prices on that excess capacity, and they do so at a regional, or more specifically zone/instance type level. So for a given Amazon region, a given Amazon zone and availability zone, and a given instance type, if there are excess capacities in the on-demand fleet, I can see that excess capacity and bid on that capacity against any other Amazon account holder. So there are some nuances with spot instances, and I don't have the time to cover off all of them in detail, but they're not designed for services that cannot tolerate interruption. Really, if you think about batch or asynchronous processes that can be interrupted and resumed, it does provide areas of optimization around cost where you can use spot instances to conduct tasks asynchronously, knowing that they may be interrupted if the spot price were to change or the capacity were to diminish. If you have bidded above the spot price and there is available capacity, you will be rewarded instances. The flag fall is 1 hour, but if that capacity changes within that hour and the instance is terminated, which is what happens is if you're outbid or the capacity is shrunk beyond making spot instances available, your instance will be terminated. If it's terminated within a given billing hour, however, you do not pay for that hour. If you terminate the instance, you pay for all hours that it's been running within that at the price of the spot rate. So typically the spot rate follows the on-demand price at around about 10%. So it is a way of doing some tasks that are capable of tolerating interruption and managing some of those optimizations. Some additional areas of optimization include use of S3 and Glacier's storage classes. Now, in Sydney, I believe the current price around S3 per gigabyte is 3.3 cents US dollars, but there is reduced redundancy storage which offers a reduced durability SLA, but also up to 20% savings, as does Glacier has a different service SLA, not around the durability, but around the availability in terms of being able to recover my objects. It imposes a 3 to 5 hour restore time. So I can start to look at optimizing some of the costs within my storage for my backup of my EC2 instances using features such as reduced redundancy, lifecycle policies and Glacier storage, as well as optimizing through use of platform services such as DynamoDB, a key value store, the specific capacity and read and write capacity units that are required. One of the key things that I would say as a learning objective is understanding as you bring your first workload into AWS and you've configured your network, you've configured your various servers and configured the availability and load balancing. In this case on the right we're looking at a pretty classic, very well documented reference architecture for serving a website where we're using Route 53 for DNS. We're using elastic load balancers for managing a pool of web servers under a auto-scaling group or fleet. Of course, CloudWatch would be used to manage the given number of instances in that fleet. We're using, in this case, the RDS relational database. It supports a number of engines such as Postgres, MySQL, SQL Server, and Oracle. And as of 2 weeks ago, we announced the Aurora database engine, which is soon to going to limited access pilot. But in this reference architecture, in this example, all of the content is still being served through our web service. And there are opportunities to offload some of that traffic and demand. If we look at that horizontal orange bar of auto-scaling web servers, it's a direct relationship between how much traffic to our website and how much virtual machines we would need to run to serve that traffic. Whereas if we look to use services such as CloudFront, S3 and caching, we can improve this design and architecture. So in this case, we can start offloading all of the static content within our web service and store that within S3, configuring that to be accessible to a CloudFront origin or distribution as an origin for the CloudFront distribution. And this means that our web servers no longer need to serve that static content. It can be accessed through the same distribution of our CloudFront distribution, but as the static content, it will all be retrieved off S3. This offers us the opportunity to scale down how many virtual machines we need to run behind our load balancer and how much traffic is hitting them, but it also drives out additional improved latency for our end users across the globe with a network of over 52 edge of the network CDN POPs that CloudFront manages. So it means that that static content will be delivered from a locale closer to our users around the globe using this. So there's really two benefits. We can reduce the latency to our end user, but also reduce the demand on our web servers and scale those down running fewer by serving that traffic. I would point out that serving the data from CloudFront is for Sydney pricing, I think it's 19.5 cents per gigabyte off EC2. It's 19.5 cents per gigabyte off CloudFront. There is the intra CloudFront population for those static assets to put them out in cache as an uplift, but that pales in comparison to the cost of running more and more EC2 instances within our environment. So this is something I would look at as you're bringing and looking at architecting your first workload, is whether or not services such as S3 and CloudFront provide opportunities to improve or reduce the amount of content that your servers need to do. Setting it up can be done with just a few clicks by going into CloudFront and creating an origin, setting up a policy and configuring your DNS to go via CloudFront for that. The other opportunity, I think, for improvement would be looking at where you can look at introducing caching. So where your web services are connecting to your database, looking at opportunities with the ElastiCache family, both Redis and Memcache, of looking at query caching for your RDS or EC2 database instances to reduce some of the pressure that's pushed on to your master database for read traffic. In EC2, under the ElastiCache family, you can configure managed, highly available cache nodes with cross-AZ clustering. Both Memcache and Redis are available within that. And these are great things to also look at with your first workload if there are opportunities to improve some of the availability and some of the scalability aspects of that workload. So there's lots of details around high availability web hosting, which is often one of the first workloads that people look at within a cloud environment, because it's a system that does have that seasonal nature of scale in and scale out. And so touching on some of those practices of using the load balancer, the elastic load balancer that will dynamically scale to meet the throughput requirements, using the auto-scaling groups to configure a behavior of adding and removing EC2 instances dynamically, and then using caching in front of your databases to enhance the amount of read throughput that you can get. There are other features such as read replicas that you may wish to consider as your application evolves. But by leveraging existing services, you can very much simplify a lot of your architecture and use highly resilient, highly available solutions as a way of doing that. The last thing I just want to touch on is looking at not, early in your journey with AWS, I should suggest that you should start to look at automation about how you're managing the environment. This gives you reusability through being able to deploy your workload, maybe just for DR and runbook to test that you can recover your workload in multiple regions through just use of copying your AMIs and copying your automated templates between regions. You can get started very easily within the console, but I would suggest trying to evolve to understand how to do these same tasks using the command line interface, as well as understand, if you are developers, what SDKs are available to use those same APIs. With the view of, in the completeness of time, making sure all of the tasks that you're using within AWS is automated through coding. This includes setting up of your infrastructure, and I would encourage you to look at the CloudFormation service that provides a model-defined infrastructure as code. So you can define exactly how you've configured your environment, your networks, your compute, your services and your databases, but also be able to keep that under code control and being able to reproduce it and consistently do so. The result is it should give you high degrees of repeatability, high degrees of consistency and accuracy about your environment, reducing environment drift, but ultimately high degrees of agility and confidence in your ability to change how you're architecting and be able to iteratively improve your architecture, being able to build duplicate copies of that and test ways that you're optimizing your workloads on AWS. Lastly, I'd like to touch on some of the tools that are available. Because this is all utility and it's very often quite dynamic for workloads for AWS, is there are tools to help you estimate based on usage patterns and behaviors. This is like a takeout menu where you can choose your regions in the top and your services down the left, and build a model which estimates how your costs will be for specific workloads. There is also on the AWS TCO calculator section a way to do this at a macro scale to understand and build a business case around an entire TCO, if that's something you're also requiring to do. The team have got skills in being able to use these, and I'd encourage you to reach out and have assistance. But then also to be able to go into the billing console and understand your actuals, looking at where you're spending money and how you're spending money. There is a very detailed cost explorer as you start to use these services to understand where your costs are being incurred and being able to look at that over time. So thank you for your time today, and I really very appreciative of you taking time out of your busy day to join this. I hope that you can attend many more of these sessions throughout the week on the various topics that they're offering. If you're looking for other opportunities to learn, we do offer in-classroom training at various locations available on our training website, which have instructor-led training, and also proctored exams for those that wish to go off and certify their skills. So the training website is /training. I'd encourage you to look at getting your technical leads certified around their skills within AWS. And for those that wish to follow for other events such as this, here are some key resources where you can follow as we post different events such as this, if you'd like to get in touch with us directly. For now, I would like to close off the session and answer some of the questions that are coming in through the FAQ.